everybody, it's Norm from Tesla, and I just got back from a demo with a new autonomous quadcopter system that's, I think, pretty impressive. Now, we've tested a bunch of quadcopters or drones, whatever you call them. I've tested before with various degrees of functionality, from transmitter-controlled drones to smartphone-controlled ones, and even autonomous quadcopter systems that can do obstacle avoidance and subject tracking. That latest feature set, we're seeing that in more drones recently, but none of them have performed to my satisfaction. They kind of don't fly perfectly or can't really sense an environment really well, and you really are spending more time keeping track of the drone as opposed to doing the cool thing you're supposed to be capturing on camera. Not so with the Skydio R1, at least in the demo that we got this morning. So let's jump to some of that footage and a chat I had with co-founder Adam Bry about the system and what makes it different.
So this is the Skydio R1, and we think it's really a first of its kind device. It's been designed for autonomy from the ground up. So it has 13 cameras on it. It sees in every direction. It has an NVIDIA TX1 at its core, and it's running a super sophisticated software stack that enables it to map and understand its environment, track people. But really the point of this product is it's super simple to use, and it makes it possible to capture amazing video that you wouldn't otherwise be able to get. So one person with a smartphone can go off into the world and capture video of themselves doing their favorite activities without having to worry about flying the drone at all.
Now, we've seen a lot of startups and companies, even products come to market that have this promise: autonomous drone, quadcopter, multi-rotor system that has a camera on it that can capture you, but the degrees of success in which you do that are wide-ranging, right? You mentioned that the R1 has 13 cameras on it, so you're doing some type of mapping of the world. How is it keeping track of you as a subject?
Sure. So the first thing I'd say about the space in general is drones over the last 5 or so years have generated an enormous amount of excitement because there's all these amazing concepts of what you might be able to do with these devices. So there's this general idea of a camera that can follow you around and capture amazing video, which has definitely generated a huge amount of attention. But really the paradigm with existing products still, at least the ones that work well, is you need to fly it. And if you're a pilot and you're controlling it, you can do amazing things. But for most people, that's still a little bit of a significant barrier to getting the value of what drones can provide. So really, like, the core bet of Skydio is on autonomy. That's why we started the company. We felt like autonomy was just a huge enabler for all kinds of different drone applications, the flying camera, but also other ones around inspection, mapping, monitoring, security. And that's really like the thing that we've been focused on. So specifically on how it tracks people. So it has 3 cameras in front. So it has the user video camera, and then it has this navigation stereo pair, and it's processing information from that to figure out what people are there and what they're doing. So every time it sees a person, it knows that it's a person because we have a deep neural network that's trained to look for people. And then it builds up a unique visual identifier. So if it were to see you, it would say, like, all right, dark blue shirt, black pants, white shoes. It would start to build up a visual identifier that it could use to tell us apart, so it could stay locked onto and tracking you.
So that combined with not just the front, but the cameras on the sides and all around, those cameras are then mapping the world.
Yeah, exactly.
And then when you say tracking and following you, that can mean a bunch of different things, right? I can say a drone follows you, and that can mean just from the back and keeping a relative distance, but you have very specific parameters that this drone can operate around you.
Yeah. Exactly. So I would say a lot of what's out there now is sort of in the pilot assist category, where it can do maybe a little bit of following, but it's designed to aid a pilot who's actually flying it, whereas this is fully autonomous. And we have a bunch of different what we call cinematic modes for how it behaves relative to what you do. So the most basic one is follow, where it tends to stay behind you. But we also have lead mode, where it's predicting what you're going to do, and based on those predictions, it tries to stay in front of you. So
I find that to be really difficult on the other drones I've tested, where, like, this is talking about it being in front of you and flying backwards, essentially.
Yeah, exactly. Yeah, so it's pretty, I mean, it's like it's looking at you from the front, and it has eyes in the back of its head, essentially on the back, which enable it to like weave around obstacles, even though it's facing you.
And still maintain a trajectory that's in line with what you're doing.
Yeah,
So
exactly.
that's predictive and also obstacle avoidance. That's the other thing. Obstacle avoidance, because you're mapping the world, because you're tracking subjects, and because it's autonomous, it needs to be able to not crash into things. Buildings, like if in this environment, for example, what is it seeing?
Yeah. So the first key thing for full autonomy is that it sees in every direction. So it has stereo pairs on the top, on the bottom, and then on all four sides around the perimeter. So there's no direction that it can't perceive its environment and respond intelligently. And we think that's really a starting point for full autonomy, because if you want to be able to trust the device, you just need to know that it's not going to hit anything from any direction. So that's where we started from a hardware standpoint. And then we have a fairly sophisticated software stack that's processing all that information in real time. So in this environment, it's going to look around, it's going to see all these trees, and it's going to represent them in 3D of areas where it shouldn't go. And then use that information when it's figuring out what it should do to make sure that it doesn't hit anything.
So it creates a localized map.
Yeah, exactly.
And as it's flying, adds that map. How big can that map grow? Can you, as you're running this for 15 minutes or so, does it keep on adding and adding and adding?
So it depends on a lot of parameters. It depends on how fast you're going, how big of an area you're flying in, how far away you are. But basically, it maps as big of an area as it needs to be able to fly itself safely and follow you and not run into stuff.
And then itself safely, distance to you, distance to the ground, what are those restrictions? I imagine if I get close to it, too close to it, that's very different than if it's looking at me from 10 meters away.
Yeah, so I think the right way to think about it is it's making intelligent decisions by balancing a bunch of different things that it's trying to accomplish. So the number one priority is not running into stuff. So no matter what it does, it's gonna make sure that doesn't happen. But then it also wants to be tracking you, it wants to be capturing smooth video, it needs to be respecting its own maneuvering limits, so how fast can it bank and turn and these kinds of things. So all of these things are constantly being traded off, and it actually predicts 4 seconds into the future of like what you're gonna do, what it might do in response to the environment to figure out what it should do, but it's doing that many times a second. So it's constantly predicting, making a decision about what it should do, and then updating that based on what actually happens.
4 seconds sounds like a lot.
Yeah.
For like if you're running through the woods or something, 4 seconds can be a pretty big distance through a lot of obstacles.
Yeah, exactly. But that's one of the things that leads to intelligent behavior. Like you could build a reactive system that just responds at the last second to whatever it sees. But if you really want it to be making intelligent decisions in a way that you can rely on it, it needs to anticipate what's going to happen a little bit into the future.
Adam, you mentioned deep learning for recognizing people. What type of objects and diversity of people in different situations? If I'm riding a bicycle, if I'm on a skateboard, how does it recognize all those?
Yeah, absolutely. So we're really building on the magic of deep neural networks here, and this is something that has just progressed rapidly in the last few years, and is one of the things that makes this product possible. So we actually leverage machine learning and deep learning throughout the system. But the place where it's most prevalent is in tracking and detecting people. So the key to this, there's a lot of keys to it, designing the network well, but one of the keys, as you mentioned, is data. So in our development process, we've flown these things in a bunch of different environments, a bunch of different activities, and we have a very diverse data set that we've collected that we use for training the thing to track people. And one of the cool things about this is every time it makes a mistake, that becomes immediately an opportunity to improve on it, because we can just take that data, label it, and then hopefully it doesn't make the same mistake twice.
Is that something that you'll be sending out in updates and doing iterative improvements as this gets into the wild and people are using it in their real world use cases?
Yeah, absolutely. So this is really like a software-defined experience. The thing that gives it its intelligence and defines the user experience is primarily rooted in the software, and that's just continually getting better. So we think this thing has really amazing capabilities now, but you can expect them to be getting pretty rapidly better as we ship software updates and incorporate feedback from users into what the thing can do.
Now, walk me back to like 4 years ago, 2014, when you guys were starting this.
Yeah.
How did you guys start and decide on this approach of using a computer vision-based system and not use sonar, LiDAR, IR to map the world and to come to this system where you have 13 cameras on a drone?
Yeah, that's a great question. So when we started in 2014, this was definitely a little bit of a science project, because at the time, the state-of-the-art computer vision results frankly, we're not good enough to build a product like this. And we looked at what had been happening in computer vision, and we felt like things were moving in a direction where it would be possible to do something like this. So from the very beginning, we made a big bet on vision. From our research backgrounds at MIT, we had worked with lasers and sonar and a bunch of different sensors, but it really seemed clear that vision was going to be the future for these devices because the sensors are super light, super cheap, and the information is incredibly rich. Something like a sonar, in the best case, is going to give you sort of like a very noisy 1D measurement of where something might be, whereas vision gives you the complete understanding of the world. It can tell you how far away things are, but it can also tell you what they are and what they might be doing. The challenge is in extracting that information and making it useful, but that's really like a software algorithmic challenge. I think we've really advanced the state of the art in robotics and computer vision in a few key places to make this possible. We're fortunate to have just a world-class team of computer vision and robotics researchers from a number of the top labs in the world. And I think one of the things that's really special that we maybe didn't fully appreciate when we started is what's possible when you bring together experts across all these different fields and have them working on the same system, which I would argue is something that's relatively new. Like most robotics research has been done in academic labs for the last 20 or 30 years, where you have people focused narrowly on a very specific problem, but not like all those pieces brought together into a complete system. So if somebody's making a person detector on their own, you might get an app that like puts a bounding box around a person, but it's never going to bring a system to life the way that this thing does when you pair it with really good motion planning and control and 3D geometry and all these things.
And these are still relatively specialized components because the cameras around here, I imagine, they can't be just like your standard drone or GoPro camera.
Yeah.
You want no blur. You need to track the world at relatively high frame rates.
Yeah. So the sensors here are specifically designed for the computer vision task. But there's nothing super magical about the sensor itself. Like it's a black and white image, it's global shutter. We've picked the lens and the exposure properties to work just right for what we want to do in different kinds of environments. But most of the magic is in the software that's processing that information. And
so you're saying that's only going to get better for people who pick this up as your software improves. Are you tapping into the full potential of your processor?
So the processor is always running pretty close to full bore, but we're also always getting better at making our algorithms more efficient. So things tend to get like compacted down, and then we can add new capabilities and make things smarter.
And so in designing a product, you're designing a power system that has to drive 4 motors and cameras and processors. That's way more than just your standard quadcopter that someone can build with a transmitter.
Yeah, absolutely. So the hardware team has done a phenomenal job in putting this thing together. Like the amount of compute and sensing that's packed into this like really sleek, nice form factor is I think pretty incredible, and one of the things that makes this product possible. And there's really no magic answer there. It's just careful engineering all the way around.
Now, it's only going to be useful if people can make great videos out of it, right?
Yeah.
So you guys have obviously experimented in a variety of scenarios, but aerial cinematography typically has a certain look to it, right? Whether you're going to get an orbit look or a standard tripod look. What are you thinking are the challenges to aerial cinematography that something like this system can help overcome, or that can create a style that's going to be new and different and lasting?
Yeah, absolutely. So one of the things that we think about and talk about a lot is this sort of dynamic perspective. And if you look at professionally captured video of sports and in movies, one of the things that really sets apart the best stuff is that the camera's always moving in interesting, cool ways. And I think that's something that's generally out of reach for most people. So the idea with this product is we want it to be like you have a film crew there with you. It's less like having a camera, and it's more like having a camera with an operator who can make intelligent decisions about what to do. So one of the things that's been really exciting over the last 6 months as we've been playing with these things internally is just seeing the kinds of content that people can create. So we've had people take these mountain biking and skiing and hiking and running, and you get video back that if you go mountain biking, it looks like you had a helicopter there that was like following you down your trail. I'm a sort of a hobbyist runner and cyclist myself, and I've taken this thing on some of my favorite climbs, and the footage you get is like filmed in the Tour de France or something. Like, it's incredible. And we think that potential is really exciting to get out there. And outside of sports, I think there's also just this creative aspect to it where usually if you want to create a video, it takes a lot of equipment and a lot of pre-planning. Like, you have a cameraman, and you have to carefully plan out like what they're going to do and what you're going to do. And with this thing, you basically just put it in the air you develop an intuitive sense for how it's going to respond to you, and then you do whatever you want. And we had a guy who works for us who basically made like a music video with 15 seconds of pre-planning in his driveway, and it looks unbelievable because this thing was just dynamically moving around and responding to what he did as he like danced around.
And you're not worrying about it crashing onto the side of the wall or something,
yeah,
hopefully.
Yeah.
Have you guys tested it indoors as well, large arena style areas?
Yeah, so because it's flying primarily based on vision, it doesn't need GPS to be reliable. So it has a GPS on there, but it'll fly fine without it. So it does work indoors. We don't recommend it in like super small scale, like an office room or a house necessarily, but in slightly larger spaces, it flies very well indoors. And in fact, we do a lot of our testing indoors in a warehouse.
Well, hopefully we'll be doing some more testing on this as well. When is this coming out, and when can people get their hands on it?
So we're announcing this product this week, and we will be shipping in 2 to 3 weeks. So we're already in production, and we're just in the final stages of logistics and validating the software. So it's available now. You can order it on our website, Skydio.com.
As you guys saw from that footage, that drone is pretty amazing. Now, I want to also cover some of the speeds and feeds we didn't get a chance to talk about in the interview. For example, the drone itself is really lightweight. It's made of a carbon fiber frame, and the center chassis is milled aluminum, keeping it relatively light because they have a lot of battery, a lot of motors, a lot of cameras, and also computer parts. They were telling me off camera that the weight of the computers they have on this actually takes 10% of the energy, not the energy it takes to run the computers or run the cameras. That's just something they have to consider when they're building this type of platform. It also has a 4K 30 FPS camera on the front, or you can reduce that down to 1080 at 60 FPS. Now, we don't know how much manual settings you'll be able to control on this camera. It's fixed at 150 degrees, which is a little wider than your typical GoPro or consumer drone camera. And that's probably because when this drone is making sudden movements, they want to keep that cinematography smooth. And so with that wide angle camera at certain distances, it's going to have a smoother video as opposed to your telephoto camera view. In storage is internal. It's 64 gigs of internal storage, no micro SD card storage, and you have to use it either view it through a phone, Wi-Fi to your phone, or plug in to your computer via USB-C on the top of the quadcopter to pull that video off. And then there were 8 flight modes with this quadcopter that we got to try out, from your very basic follow mode to your orbit mode to a tripod mode where it just stays in one place and moves its 2-axis motorized gimbal to follow you. But the mode that I was the most impressed with was the lead mode. This is where the quadcopter tries to stay in front of you and flies backward while you move forward. So that could be you walking forward, bicycling forward, or snowboarding down a hill. And they showed us some footage that was really, really compelling in that lead mode. It's not an easy thing to do. In many of the other drones that we've tested that have subject tracking, when it flies in front of you, it tends to weave off axis because it doesn't do a good job of tracking your trajectory. Here, they're saying that they can predict your movements up to 4 seconds ahead. So if you're walking in any bit of a relative straight line, it's going to stay in front of you as if there's a person holding a steady cam in front of you moving backwards. Now, the maximum velocity speed of this quadcopter is 25 miles per hour, which, yes, is slower than, for example, your DJI Phantom 4s in sport mode, but obstacle avoidance is mandatory at all times. So 25 miles per hour with obstacle avoidance is actually pretty quick. And that gave us some really interesting shots where the drone was weaving between trees at faster than running speed as I was running away from it and running toward it. And we couldn't get it to fall down or hit a tree or hit a branch at all. That was really, really impressive. It can get up to 3 meters close to you, that's about 10 feet, while still keeping you in focus and tracked, and as far away as about 10 meters away from you. And then it wants to keep about roughly 2 meters away from every obstacle, so it won't get super close to a tree. That 2 meters gives it a buffer time so it can slow down or change its vector, change its trajectory to move around that tree, and that applies for the ground as well. It won't get closer than about 2 meters from the ground. Using the app, you can control control it with your 2-stick transmitter on-screen app with a viewfinder on the screen, and you can also zoom and manually move the quadcopter around your subject. And it was really impressive to look at the app and see how it recognized all different subjects in front of it. There were icons placed in front of each of us that we could tap to say follow this person and follow that person. But we were able to fool it once or twice when it lost tracking of one person. We did a sudden move and then it jumped and latched onto another subject that was wearing similar colored clothing. In an ideal scenario, it would reattach to the person when they jump back into frame. Now, we couldn't get it to crash into a tree, but that's not to say that it's going to be perfect, because it is still an optical-based system. The 13 cameras that the quadcopter has around it, they're just black and white, high shutter speed cameras, but they do have to compensate for the lighting that you're going to be in, whether it's going to be a bright environment or a dark environment, exposure changes. And so while it was successful at navigating around trees, we don't know whether it would recognize something like a thin branch that was in the sun that might have high reflectivity that it might not know it's there. So we'll have to put it through its paces when we get the quadcopter in, and also we don't know how it will perform in indoor environments like this room with high ceilings, or even something like a basketball arena. I think Skydio has a lot of potential in their computer vision system. They definitely have a lot of confidence in their system in that they let us take it out into a wooded area and run through the woods with it. And they're obviously thinking forward and thinking about what other type of deep learning environments and subjects can they train their system on, so it's not just recognizing people. We obviously want these quads to be recognizing animals, cars, other objects, and there's just so much potential in the future for this type of technology. It might even change the way we think about consumer drones and camera drones in the future. So I can't wait to test it. It's coming out in 2 weeks, and you can pre-order now. Information is below. Thanks for watching this video. Go like it, subscribe to our channel, and we'll see you next time. Bye.